Characteristics of X-ray spectra. We have mentioned that the spectrum of X-rays consists of a continuous spectrum upon which is superposed a line spectrum 18.8. The distribution of energy in the continuous spectrum depends only upon the potential difference across the X-ray tube, while the line spectrum is characteristics of the target. These are called characteristic spectra and were investigated by Moseley in 1913 by making each element in turn the target in an X-ray tube. 39 elements extending from aluminium to gold were examined in this way. The X-ray were analyzed with a Bragg crystal spectrometer. Most elements showed two groups of lines, one generally less than about 0.1 nanometer called the K series, and another greater than 1 nanometer and called the L series, similar to figure 18.8. The wavelengths of the L series were roughly 10 times as great as those of the K series. For elements whose atomic number exceeded, further series appeared which were called the M and N series. The characteristics X-ray spectra can be explained from the principle of inner shell transitions. The electrons of an atom are ordered according to their arrangement in shells about the nucleus. Each shell has a certain maximum number of electrons. There is a rule that the number of electrons in the ninth orbit is equal to 2n square. According to this rule, there cannot be more than 2, 8, 18, 32 electrons in the orbit or shells for n is equal to 1, 2, 3, 4. These orbits or shell are called K, L, M, N for n is equal to 1, 2, 3, 4 respectively. When highly energetic incident electrons knock an electron from the K shell, there occurs a vacancy in that shell. This vacant space in the K shell is filled by an electron from the L shell, giving up energy in the form of an X-ray. The radiation, which characteristics of the target material, is labeled the K alpha line. The electron in the M shell that fills a vacancy in the K shell gives up energy as an X-ray called the K beta line. These transitions from the shell L, M, N and so on to the K shell give rise to a series of lines K alpha, K beta, K gamma, and so on called the K series. When incident electrons dislodge electrons from the L shell, these are filled by electrons from the remaining M and O shells, etc. These transitions give rise the L series, the first line of which is L alpha. The nomenclature of these transitions is illustrated in figure 18.9 and 18.10. Upon closer observation, each of the characteristics X-ray line is found to be composed of a number of closely spaced lines called the X-ray fine structure, the explanation of which is not taken up here since the topic is beyond the level of this book.